Okay, so this is one of my favorite lessons. This is where I get to teach you how to find derivatives of products and of quotients. Okay, so hopefully you remember, but I'm going to say it anyway. A product is where you multiply two things together. Okay, so if you're looking here at this notation, I am multiplying the f function by the g function. Okay, here's the rule. You're going to take the first function times the derivative of the second, and then you're going to add that to the second function times the derivative of the first. Okay, so now down below, the quotient rule is a little more involved. I'm going to write it up first, and then I'll tell you how to memorize it. Okay, now I know that magically appeared in front of you, but you can always pause and write it down. But I'm going to highlight it as I'm saying sort of this little thing that I got taught when I was in high school to help you memorize this. So let's just start by recognizing that the g is the low function and the f is the high function, right? Just low in that it's on the bottom, and f is going to be high as it's on the top. Okay? Here's how it goes. It's low d high minus high d low, square the bottom, and away we go. All right, again, that's how I got taught it in high school. It has never failed me. I will do it again. All right, low d high minus high d low, square the bottom, and away we go. Okay, so you'll hear me say that over and over and over again. That's how I remember the quotient rule. Okay, so now let's try some of these problems. So for the first example right here, it's asking us to find the derivative of this product. There are two things here that are being multiplied together. There's this first function and there's this second function. So for the derivative, it's the first times the derivative of the second plus the second times the derivative of the first. All right, now you'd think I'd be nice and let you leave it that way, but you all know by now I'm not nice. So this I have to distribute, and this I need to FOIL. So my next line is going to look like this. 3x to the fourth plus 15x to the third. That's what I got by distributing. And then over here, when I FOIL, the first term's 2x to the fourth. One of the outers is 5x to the third. The inner is negative 2x. And the last is negative 5. And then, yes, you do need to clean that up. Meaning, if there are like terms, you need to put them together. And I do see some things that are like, right? There's 3x to the fourth and 2x to the fourth. There's 15x to the third and 5x to the third. Those are like. You just have to put them together. So I end up with 5x to the fourth plus 20x to the third minus 2x minus 5. All right, there you go. That's your first product rule. Let's try B, which is going to be your first quotient rule. All right, so I'm going to use dy dx. Check out that notation. All right, here we go. So it is low d high minus high d low, square the bottom, and away we go. Okay, so let's see if I probably should have written a little smaller. Let's see what I can do here. So multiplying along the top, I get 6x to the third. Here, and this is going to seem weird, but I am distributing negative 2. So negative 2x cubed minus 8. My denominator, when I square it, is 4x squared. All right, so then the last little bit is combining your like terms, which becomes, what, 4x cubed minus 8 over 4x squared. Oh, look, that's reducible. What I mean is all three terms, so this one, and this one are all divisible by 4. So x cubed minus 2 over x squared. Okay, there's your first quotient rule. Now let's take a look at the next page and see what this chart thing is all about. Okay, so as I'm reading, you're given a table containing some values of differentiable functions. That means I'm allowed to take the derivative. Use the table data and the rules of differentiation to find h prime of 2. Okay, so in English, that means that I need to find first the derivative. And once I know that formula, I'm going to plug in 2 for x. All right, here we go. So it's the first times the derivative of the second plus the second times the derivative of the first. And now I need to put a 2 in for all of those x's. Okay, and then this just becomes reading the table correctly. F of 2 is this number. G prime of 2 is that number. G of 2 is this number. And F prime of 2 is that number. So if I'm not mistaken, this is 6 minus 4. That means h prime of 2 is 2. All right, let's try this with B. Same sort of situation. Let me erase some stuff that's in the way there. Okay, so this one I'm using the product rule. So low D high minus high D low, square the bottom, and away we go. All right, so now I'm just going to be putting 2's in for all of those, right? So G of 2, F prime of 2, minus F of 2, G prime of 2, all over G of 2 squared. Okay, so now back up in the chart, I just got to make sure I get the right numbers in the right spots. So 1 times negative 4. That looks atrocious. Let's try that again. That's a little better. Minus F of 2, which is 3. G prime of 2, which is 2. And then G of 2 squared. Okay, so what do I end up with? Negative 4 minus 6 is negative 10. It's over 1, but I'm not going to write that down. Okay, let's keep going. All right, so this one's, okay, this is not going to be the same answer because check out my numerator and my denominator are different, right? So let me write up the rule. Here we go. It is low D high minus high D low, square the bottom, and away we go. So now I need to put 2's in there, all right? And I think you're going to be okay if I don't write it with the 2. So 3 times 2 minus 1 and negative 4, and then 3 squared. And then simplifying this, 6 plus 4 over 9, that equals 10/9. Okay, so I'm on this last one now, h prime of x. Okay, so this right here is a constant times a function. So when I do the derivative, it's the constant times the derivative. Okay, same situation's happening over here. So I'm going to have minus 2, but this is a product. So I'm going to have to do the first times the derivative of the second plus the second times the derivative of the first. Okay, and now when I go to put 2 in here, I'm going to have 3. F prime of 2 is negative 4 minus 2 times. Now, if you look really close, we did this calculation before. It is from part A. It's right here. Okay, so if you look back up there and you see what we got as far as an answer, it was 2. Oh, that's the wrong thing. It was 2. So that means that h prime of 2 is equal to negative 12 minus 4, which equals negative 16. Okay, so again, I'm looking at this page. That's a lot of writing, and it's a lot of information. It's only 2 formulas, but if any of it is confusing, please come see me during tutorial. All right, so I only have one more page on these notes, and they're asking me to derive the formulas. Okay, what that means is, I'm hoping you recognize that tangent is actually the same thing as sine over cosine. Okay, that is what I've written is equivalent. I haven't done a derivative or anything yet, but those 2 things that you're seeing are equivalent. All right, which means I should be able to do the quotient rule on this thing. When I actually go to do the derivative of the tangent of x with respect to x, it's going to be low d high. You have that memorized. Minus high d low. Square the bottom, and away we go. Okay, so now let me simplify this just a little bit. So this part here multiplies to be cosine squared x. And then this part here multiplies to be positive sine squared x. If you're wondering why it's positive, it's because of these 2 negatives. That's why it's positive. Over cosine squared x. This numerator, that's the big kahuna, you guys. That's the most important, the Pythagorean identity. We end up with 1 over cosine squared x, which is secant squared x. That's why the derivative of tangent is secant squared. Okay. Now again, I made you memorize it, but in case you wanted to know why. All right. So I'm going to try and do B as well. Apologies, but I am going to have to move or erase this previous calculation. So give me a sec. Okay, so I moved it, made it a little smaller. Here we go. So secant, if I rewrite it, is actually 1 over cosine. All right, so I'm going to do the derivative with respect to x of secant x by using the quotient rule. So it's the low times the derivative of the high, which is 0, minus the high times derivative of the low, which is negative sine x, squaring the bottom, and away we go. So when I go to simplify this, this part right here becomes 0. It just goes away. So that when I multiply what's left, I end up with positive sine x over cosine squared x. Okay, now if you're wondering, well, how does that become tangent secant? Let me rewrite this in an equivalent form. This is the same thing as sine x over cosine x times cosine x. Now, kind of depending on how well you know trig, sine x over cosine x is tangent x, and 1 over cosine x is secant x. That's why that derivative is what it is. All right, so now let's take a look at number 4. This is going to be a product rule. right? I'm going to do the derivative of y with respect to x. It's the first times the derivative of the second plus the second times the derivative of the first. Okay, now these two terms, there are two here. Let me underline them for you. This is one term, this is another. They have a GCF. There's a greatest common factor in there of x squared. So when I factor that out, I end up with x secant squared x plus 3 tangent x. Okay, again, just factoring. I took out the greatest common factor. All right, so now this last one, let me give myself some room here. It's a quotient rule. Okay, so here we go. The derivative of y with respect to x. So low d high minus high d low. Okay, now I want you to think about this before I write it down. The derivative of that constant is 0, and the derivative of negative cosine x is going to be positive sine x. All right, square the bottom, and away we go. All right, so let me simplify the top, okay? I'm going to show you what I'm doing here. Distributing here, okay? And here, multiplying these two together. So 2 cosine x minus cosine squared x minus sine squared x over 2 minus cosine x squared. Okay, now this is going to be some very cool algebra, but it may take you a second to see it. If I factor out a negative out of these two terms, it looks like this: cosine squared x plus sine squared x. And now the stuff that's in the top parentheses is 1. And I end up with 2 cosine x minus 1 over 2 minus cosine x quantity squared. Okay, again, algebra, algebra, algebra. All right, I'll see you tomorrow.